Most people look up at Jupiter and see something beautiful. A giant marble hanging in the dark, painted in amber and cream, peaceful, distant, safe. But that image, that's the lie Jupiter tells from far away. Get close enough, and the beauty disappears. What's left is something our instruments weren't built to survive, something that rewrites what you thought you knew about this solar system. Today, we're talking about what Jupiter actually is, and I promise, it's nothing like what they taught you in school. Before we get into the scary stuff, we need to establish one thing: scale. Because when people say Jupiter is big, they're not doing it justice. More than 1,300 Earths could fit inside it, not beside it, inside it. Its gravitational pull is so dominant that every other planet, moon, and rock in this solar system combined doesn't even come close to matching its mass. Here's the thing that keeps physicists up at night, though. Jupiter almost became a star. We're talking 80 more units of mass during formation, and we'd have had 2 suns. 2! Our entire planet, our entire existence might have been erased before it started. So we got lucky, sort of. Instead of a star, we ended up with something that has all the hunger of one without any of the warmth. That iconic swirling surface, let's clear something up. That's not a surface, that's the atmosphere, and it is absolutely brutal. Take the Great Red Spot. That single storm system has been spinning continuously for at least 4 centuries, maybe longer. We genuinely don't know when it started, and it's big enough that our entire planet would disappear inside it. Wind speeds around its edge hit 400 kilometers per hour, and that's the calm zone. Go deeper into the atmosphere, and jet streams are screaming past at over 600 kilometers per hour. We're talking velocities that break the sound barrier, not in space, on Earth. These are walls of gas that would shred anything we sent into them, and that's just what we can see from the outside. Here's a concept that genuinely messes with your head. Jupiter has no ground. None. If you fell into Jupiter, you wouldn't hit anything. The atmosphere just gets denser and denser and denser. The pressure doesn't stop climbing. Eventually, you reach a layer where something wild happens. Hydrogen, the same element in the water you drink, gets compressed so intensely that it stops behaving like a gas. It becomes a metal, a liquid metal. Liquid metallic hydrogen. And that substance is responsible for the single most dangerous feature on this planet: Jupiter's magnetic field. Ours protects us. It's a shield. It catches solar radiation and bends it around the planet so life can exist. It's one of the reasons Earth is habitable. Jupiter's magnetic field is 20,000 times stronger. If you could see it, it would look bigger than the moon from where you're standing right now. It stretches across millions of kilometers of space, all the way out towards Saturn. It is the single largest structure in the entire solar system. And it is not protecting anything. Instead of deflecting charged particles, Jupiter catches them, accelerates them, flings them around at nearly the speed of light. The radiation belts this creates are so dense and so energetic that a human being caught inside them would be dead within minutes. NASA knew this when they built Juno. The spacecraft carries a sealed titanium vault, 200 kilograms of shielding, just to keep its computer chips alive. And even then, Juno's close passes last only a few hours before the radiation exposure becomes critical. One of our earlier probes, Galileo, took a radiation hit on its way into Jupiter's atmosphere equivalent to 25 million dental X-rays. Shortly after, the pressure finished with the radiation started. What I find most unsettling about Jupiter isn't any single danger. It's the fact that this planet has been running the show since the very beginning. Early in our solar system's history, Jupiter migrated. It drifted inward, closer to the Sun, plowing through the inner solar system like a wrecking ball. Every protoplanet in its path either got absorbed or scattered into nothing. Mars, by the way, was supposed to be much larger. Jupiter stunted it. Scientists call this the Grand Tack Hypothesis. Jupiter swept inward, then Saturn's gravity eventually dragged it back out. But the damage was done. The asteroid belt you see on every solar system diagram? That's not the remains of a planet that exploded. That's the remains of a planet that never got the chance to exist, because Jupiter kept tearing the building blocks apart before they could assemble. And this isn't ancient history. Jupiter is still doing this right now. In 1994, we watched comet Shoemaker-Levy get captured by Jupiter's gravity, ripped into 21 separate pieces, and then each one after another, slammed into the planet at 60 kilometers per second. The explosion scars were bigger than Earth. The energy released was in the range of millions of nuclear warheads going off simultaneously. If that comet had found a different path toward us instead, we wouldn't be here. Does Jupiter protect us from this kind of thing? Sometimes, yes. It hoovers up debris that might otherwise come our way. But it also acts like a slingshot, redirecting objects inward. It's a complicated relationship. Jupiter is simultaneously our bodyguard and the reason there's so much dangerous stuff out there in the first place. Now you might be thinking, okay, Jupiter itself is a nightmare, but what about its moons? Europa has a liquid ocean under all that ice. Scientists genuinely think there could be life there. That's promising, right? Well, yes, and also no. Let's start with Io, the closest of the large moons. Io is the most geologically active object we've ever found. It's covered with hundreds of active volcanoes, constantly resurfacing itself. But here's the thing. This isn't driven by internal heat the way Earth's volcanoes are. It's driven by Jupiter's gravity physically squeezing the moon over and over, generating so much friction that the interior never cools down. Io is being kneaded by a gas giant like it's bread dough, permanently. Europa is more exciting, and also tragic. That subsurface ocean is real, and it's a genuine candidate for extraterrestrial life. But Europa orbits deep inside Jupiter's radiation belts. The surface radiation levels are high enough to be lethal. Any lander we send there will need to drill kilometers through ice just to reach water that might be shielded enough for electronics to function. And Ganymede, the largest moon in the solar system, bigger than Mercury, actually has its own magnetic field, the only moon anywhere that does. But even its own magnetic protection isn't enough to fully block Jupiter's influence. These moons don't orbit Jupiter, they endure it. I want to make sure the full picture is landing here. Most things in space are dangerous in one specific way. A neutron star has intense gravity. A magnetopar has insane magnetic fields. Supernovae have radiation. Jupiter has all of it at the same time, always. Pressure that would collapse any known material. Radiation that kills unshielded electronics within hours. Gravity that alters the paths of planets. Storms that have outlasted entire human civilizations. A magnetic field larger than Saturn's orbit. There is no safe zone around Jupiter. Every spacecraft we send is working against a clock, and the clock always wins eventually. And the kicker? Jupiter isn't done. Right now, today, it is still nudging asteroids, redirecting comets, and slowly tugging on the orbit of every object in this solar system. It is still shaping what lives and what dies out here. Given all of that, why do we keep pointing spacecraft at Jupiter? Because everything that makes Jupiter terrifying also makes it one of the most scientifically valuable objects in the known universe. That liquid metallic hydrogen deep in the interior, we can't create those conditions in any lab on Earth. Studying it from orbit gives us a window into how gas giants form, not just here, but across the galaxy, around other stars. It changes how we understand planetary science entirely. The radiation environment is essentially a natural particle accelerator. Physicists study it to understand how charged particles behave in extreme magnetic fields, which has applications for everything from fusion energy to understanding cosmic rays. Since Juno entered orbit in 2016, we've learned things that completely rewrote our models. Jupiter's core isn't the hard, dense ball we assumed. It's diffuse, fuzzy around the edges, possibly still slowly absorbing leftover material from the solar system's early years. Billions of years later, it's still growing. The storm systems don't just skim the surface, they extend hundreds of kilometers downward into the planet. What we see from space is just the top layer of something far deeper and stranger. And Jupiter's auroras, the light shows at its poles, are powered directly by Io's volcanic activity. Material from the volcanoes gets ionized, funneled along magnetic field lines, and lights up the sky in a display that makes Earth's northern lights look like a candle. But for all we've learned, Jupiter stays fundamentally out of reach. We can orbit it, we can probe it, we cannot set foot on it because there's nothing to set foot on. We cannot establish a presence there. The environment is simply incompatible with human existence in any form we can currently imagine. It's a hard limit, and that's rare. We have plans for Mars, we have ideas for Venus. Jupiter? Jupiter just says no. Jupiter has existed for 4.5 billion years. It was out there before the first microbe appeared on Earth, before the oceans formed, before our sun settled into its current state. And when our sun eventually expands and swallows the inner planets, Jupiter will still be there, still spinning, still storming, still pulling everything around it into its orbit. Next time you look up and spot it, and you can see it with the naked eye on a clear night, that steady, bright point that doesn't twinkle, just remember what you're actually looking at. You're looking at a storm system that has been rotating for longer than human civilization has existed. You're looking at a radiation environment that would end your life in minutes. You're looking at the gravitational force that decided which planets got to exist and which ones didn't, including, possibly, the one you're standing on. Jupiter isn't the king of this solar system because it earned some kind of respect. It's the king because it outlasted, outmuscled, and outweighed everything else, because nothing ever got powerful enough to push back. That's Jupiter, and honestly, I think it deserves way more attention than it gets. We talk about black holes and supernovae, but this thing is right here in our own backyard, doing things that still don't fully make sense to us. If this changed how you see the solar system, hit subscribe. I've got a lot more of this coming. See you in the next one.